Hi, my name is Daria Orlowski, data librarian. I'm here with Jason Glatz, math specialist, and we're here to give you a basic introduction to visualizing your data as part of Library Skills Week. We will start off with some best practices for both graphs and maps, discuss different types of visualizations and their purpose, as well as some real-life examples that could use some improvement, and finally, provide some software options for visualization creation. So without further ado, let's get started. Okay, so the first thing we want to know, because this is a virtual meeting and we don't get to see all of you and it's kind of hard to participate, is tell us about your experience using data. I'm going to go ahead and open a poll. You can take just a minute to tell us what your data experience has been thus far. Great. So I think everyone has finished and no one has responded what's a bar chart, which makes me very happy because it means that at least we have the fundamentals down. Right, Jason?
Exactly.
So yeah, let's see, these slides are giving me a hard time with advancing. So just before we get right into the meat of the presentation, we just wanted to tell you a little bit about what we offer in our roles at Waldo. So I offer any data services, pretty much any questions you have regarding data at any point in your project or research, whether that's writing grant proposal or finding data or starting a workflow or documenting or managing your data during your project, I am here to help you. So please reach out if you have questions after this presentation or would like to continue the conversation.
Right. And so as my title would imply, I am the map guy here. In addition to kind of running the reference and maintaining the map collection, I also have a service to all community members where we can collaborate together and make a custom map for your research. It generally is you provide me the data. I'm not a research assistant, but if you give me the data, I will make the map. Primarily, it's for publications, journals, and books, and theses and dissertations. Occasionally, I will do a project that will help a class out, or somebody who's just doing general research. And I also do occasionally work on digital projects like online mapping and story maps, which we'll touch on briefly later on.
Okay, great. So I'm going to jump right in then. So data and its uses. We asked you really briefly about what your data comfort level is. And I'm going to ask you one more question. What do you hope to get out of this workshop? Just to kind of give us an idea of what to maybe touch on while we're going through this presentation, because this is very much going to be a back and forth sort of example-driven presentation. So just a phrase or two about what you're hoping coming into this workshop.
So along those lines as well, if you have a question or comment that you'd like to make, you can put it into the chat, and myself or Daria will be kind of monitoring that and chiming in as necessary.
Yes. Doesn't have to be anything crazy. If you don't know, like Jason said, chatting is perfectly fine. We'll be monitoring that as well. But if you're feeling particularly shy, this is a good way to privately tell us your thoughts. I'm just going to give it another maybe 30 seconds or so. Don't have to wait for the entire 5 minutes. waiting on a few people to finish up because I see that there's still a few in progress. Okay, so while that's being finished up, I'm going to go ahead and close it off now. So please submit what you have so that we can keep moving forward. And in the meantime, we will go. Oops, that's not what I wanted to do. We will go and advance the slides. So the first thing we wanted to talk to you about is some tips about data when you get started and you're starting to visualize things that you should take into consideration. So the first two are pretty straightforward, keeping it simple and labeling for clarity. And right here we have two examples. The first one on the left-hand side looks pretty simple, but if you start reading it, you have Black Women's Equal Pay Day, 8 out of 13, symbolizes how far into the year Black women must work to earn what men earn in the previous year. Unfortunately, it's not exactly clear about what's going on here. Is it that Black men must work one day in order to make what they have made in the previous year, and Black women need to work 226 days? Or is it 366 days for white men and 365 plus 226 for Black women? So it's very important when you're creating visualizations to do a sanity check and to make sure that the way that you're presenting data is actually clear and not that you're creating extra text that maybe will confuse your audience. The other example to the right here is a graph that's taken from a publication that looks like a line graph and a timeline, and maybe something that should have been presented as a bar graph, because you have a number of mentions of when H1N1 was talked about in various publications and in the news. The next two tips would be sorting your data and choosing your colors carefully. So on the left-hand side, we have two pie charts. The first thing you might notice is that the colors are super monotonous. You can say they're very similar to each other, and it might be a little bit difficult to figure out which categories relate to which colors. The other notable thing that you might notice is that they're not sorted. So you have the largest percent, 28%, is on the top right, which is correct. But then you have 11%, and then you end up having larger and smaller percentages follow, kind of mixed up in between that. The other thing is choosing your colors carefully also can relate to color blindness and how others may perceive colors on the spectrum. And this is definitely something that Jason can talk to more about regarding maps.
Yeah, so there's just a couple of points about this, and I have to confess that I have not always been the best about keeping track of color blindness. Esri, the mapping software that I primarily use, is doing better at this over time with the color scales that they're using. But in short, you know, if you have one of these three flavors of color blindness that are shown on the right of this graphic, you know, you would have a very hard time telling orange and green apart, to the point where if you were using those as symbols, they would look virtually identical. And then also, this applies to infographics as well as maps, is kind of just a general design principle, is you really kind of want to stay away from really vibrant and bright colors, unless you want to use that as an accent to emphasize something. So if you look at most good maps, you'll notice that they are kind of have a desaturated kind of pastel or not very vibrant look to them. It's just something to keep in mind if you're using defaults that are very bright.
Yeah. And on the flip side of it, you should also do, again, a sanity check, whereas you have like pie charts that are represented here that may be way too much desaturated. You have colors that are too similar to each other. So being aware that you have enough contrast that you can tell categories apart is also important, especially if you're not dealing with maybe a gradient as you are in maps. And we'll get to that a little bit later. More tips. Identifying a relation within the title and subtitle is important. Telling the audience what they're looking at is always a good thing. You should be able to look at your visualization and be able to orient yourself. And scaling accurately is also important, and we'll get into lying or misleading your audience. But on the left hand here, we have an example, COVID-19 cases in the US. And if you could just type in chat really quickly what you think the issues with this graph are, if you feel up to it, tell me your thoughts. What's the first thing that jumps out at you? Labels? Yeah, exactly. What is the scale? Maybe it looks like dates, yeah. But what else about, if you look at the dates, you go from the 21st of February to the 1st of March. Yeah, it's kind of weird. It's like, it jumps around, but not consistently. It's not advancing day by day. It's like a couple of days here and then more days there. So the scale is weird. And then if you look at the y-axis, it goes from 0, so grade on them, they start at 0, which sometimes scales don't do. But it goes from 50 to 65,000, which is maybe not the most truthful thing to do, because you end up with a curve that does not move as drastically as reality. The other thing here on the right-hand side is you have another visualization that is, someone has stylized it to make it interesting. It kind of looks like it could be a bar graph, except it's shown by mallets to represent judgeships, presumably. But what is the thing that you notice here? Any thoughts? Yeah, no title. There's a small title at the very bottom, but yeah, it's kind of hard to read. And then if you look at like Barack Obama, so these are labels for presidents. I know it's a little hard to see. And he's at 15 appointments. And Donald Trump is at 24. Between 15 and 24, that's quite a bit of a difference in terms of being skewed. And it's only like 9 points away. So the way that it's being represented is it's clearly has its own agenda about what are the differences between appointments for presidents, which might not be as big as are depicted within this graph. Additional tips: be consistent across your graphs, especially if you're presenting more than one graph. Jason has put a visualization there. You want to say a few words about it?
Yeah, so this is from the Washington Post just a couple of days ago. It is a common kind of infographic called a small multiple. The idea is that, by putting each week scaled to the same scale, you can easily compare them across the board. And if you look, I believe, if I remember correctly, Postmaster DeJoy came into power in the 18th. And then you can see, Daria, there's some kind of, at least on my screen, there's a big gray box over the slide now.
Oh, how about now?
Now it's good. Yeah.
Okay, sorry.
So you can see that once he basically came into power or came into office and instituted a number of his reforms to save money, there was a dramatic increase in the number of late mail deliveries starting at July 16th.
Yeah, and the thing that this visualization does really well is it keeps the maps and the colors of the maps consistent so that you kind of know you're looking at the same thing and you can easily compare that. contrasting to the visualization that I put up, which isn't super great, is a 3D graph, which in most circumstances you want to do your best to avoid. It may look really good, but the problem is that in order to fully appreciate it, you really kind of need to rotate it, because you have instances where you have bars that obscure other bars, and you even have something which is a no-no in this graph, in addition to it being a 3D graph. Anyone care to tell me or have any thoughts about what immediately jumps out at you in terms of scale and skewing that are maybe not the greatest choice in this visualization? I mean, there's also no title, which is not great, and we don't have any labels. But one of the things is that you have these little zigzags across one of the bars, which kind of, I think they were trying to represent that there's a jump, but the scale ends at the y-axis at 140, and one of the blue bars goes to 435. Yeah, so the largest data point is way off scale. And also, yeah, the colors, it's not super clear what they're supposed to symbolize. It kind of looks like they might relate to a certain category, but it's not super clear either. Okay. Other tips: use the right type of visualization for your data. It can sometimes be confusing with all the visualizations out there to know which one you should be using. But let's take it, for instance, the one on the left-hand side, which is a photo of a visualization that was used in the news. What are some things that immediately jump out at you? The title is Biggest COVID-19 Worries. Labels are Getting It, Family Getting It, The Economy. Yeah, the pie graph adds up to more than 100%. Exactly. And so you have 68, 62, and 48. The other questions I would have is, whose biggest COVID-19 worries? And are there any overlaps between these categories? So on the right-hand side, you actually have the same type of poll that was used to create the left-hand side one, but split up into a bar graph, which is actually a much better data visualization for this information, because categories can be mutually exclusive and they don't have to add up to 100%. And in this case, we get a little information, such as America's biggest COVID-19 worries. And we also get, in addition to that, the amount of individuals who were surveyed, because that also matters to know how big your sample size was, so that we're not just dealing with someone who talked to 10 people off the street. Last category of good tips is don't lie with your data. It is actually very easy to lie with your data, and we ask that you make a good effort to try not to do that. We talked about some of the things that can be problematic, like not having a reference point, something that doesn't scale well, and doesn't start with 0. So on the left-hand side, you have a graph of Obamacare enrollment. So they're using a bar graph, which is good, but the one on the left is 6 million and the one on the right is 7 million, and it doesn't start with 0. So the 6 million looks a lot smaller than the 7 million because there is no reference point. Could also be argued that the scale may be skewed. We have no idea. There are no labels of how much those data points are increasing on. Another example of that is the graph on the right-hand side, which looks at average global temperatures by year. And clearly someone had an agenda here as well, because global temperatures don't vary that wildly. And they have decided to create the y-axis that increases in increments by 10, which means that any variation that we're seeing by year looks like a straight line in the zoomed out version, when really they should have been zooming in within 50 to 60 so that we can see the variations. Additional things. What data is missing is a question that you should always be asking yourself when you're looking at data visualizations. For example, on the left-hand side, we have a tweet by the president with some data about approval ratings among Republicans, which is very small, but it is still there, saying 88% approval, 9% disapproval. There is a source, so that is great. But as you can see on the right-hand side, in an additional data visualization from where this data came from, under the Republican category, strongly approve is 64, somewhat approve is 24, somewhat disapprove is 4, and strongly disapprove is 5. So what really happened is someone condensed those categories together so that you have approval much higher, missing those nuances because they're taking all the approval as one category and all the disapproval as the other. And the other thing that sticks out is it's just among Republicans, so it's among the party that already he's coming from and he's representing. So that can also be skewed, so you're not getting representation from the other parties. What's the other thing that maybe sticks out to you that we're missing from this visualization? Doesn't add up to 100%. I didn't add up the numbers, but I trust your math. I think the other thing is that we don't know, how many people fall in the various parties? How many people were surveyed for this? Was this like 10 people off the street? Was it 100? Was it 1,000? That can really influence what results we get, in addition to how were they surveyed. Were they surveyed off the street? Were they called? Was this an online survey?
Well, and Daria, that also kind of brings me to one of my pet peeves is when people take online surveys and, put them forth as if they are legitimate randomized sample surveys, and so it's like anybody can go and vote, multiple times or, there's no kind of scientific legitimacy to an online poll other than just fun.
Yes. And it could give you some information, but it might not give you an accurate picture. And you, as the audience, should always be on the lookout for these kinds of things when you're trying to verify your sources. Another thing of lying with your data, cherry picking your data. This one is harder to spot in the wild because a lot of the time you are also missing some data. So for example, on the left-hand side, you have the unemployment rate between 2002 and 2009. And this is very clearly showing that depending on what your starting point is and what your ending point is, you can cherry pick the information that you're giving to the audience. So if you're starting at a time when the unemployment rate was particularly high and ending at a time when it goes down, you're like, well, best president ever, right? The unemployment rate went way down. But you can also take that same time frame and pick a point where unemployment is very low and it goes very high, and you can make a counter argument. An additional example of that is on the right-hand side, you have two graphs in which there was one data point that was cherry-picked, I think in April of 2009, to show that the Arctic ice area was actually marginally larger than in 1989, and to make a claim that we are actually doing well and maybe global warming is not impacting us. However, someone clearly went and tried to find this piece of data to make this claim, because if you look at the annual average Arctic ice extent, so how much Arctic ice overall there is over the course of years, it is a steadily decreasing curve, which is important to have the bigger picture when we're looking at a smaller subset of data. It's almost, and I think this is the final category of don't lie with your data, misleading colors. We kind of talked about that a little bit in terms of picking the right types of colors. But in the example on the left-hand side, you have something about states with the most sexually transmitted infections. And someone here created a visualization, which could be accurate, but for some reason they decided to flip the scale. And so the states that are the darkest, that you might think actually have the highest rates of STIs, actually have the lowest rates of STIs in this visualization. So this is not maybe the best sort of visualization, can be misleading. The one on the right is a type of visualization where it shows password security and how strong your password is. But even though the data is saying one thing, there are colors that are highlighting another thing. So this is coming from a business that deals with password protection and password managers. And they may have some vested interest in having someone create a more complicated password so that they need to use their product in order to remember the password, where in fact, having a simpler password combined with upper and lowercase letters actually takes longer to crack if you have more characters than some of the other options that they're highlighting in green. Anything you wanted to add, Jason, at this point? Or does anyone have any questions?
Nope, I'm good.
Okay, great. So I think giving those examples of good practices and things that you shouldn't do to mislead your audience, it's also very important when you're looking either at different visualizations you find online or creating your own visualization, is to really know the data. So what is the source? Is this a reliable source? Does the visualization have a source that you could go to? Which population is represented or is not represented within your visualization? Is the data raw? Has it been manipulated in any sort of way? Is there some sort of reference to that? If you are reusing data, was there an exclusion criteria that was implemented? And was that reasonable? And are you missing data that within your data set that needs to perhaps be supplemented in order to get something more represented? And how are things are blank or just no response? How are those treated within a visualization or within a data set? So on the right-hand side, we have an example of Americans who would say they would get a COVID-19 vaccine if it was available to them today. So is there anything that jumps out to you about this visualization, keeping in mind some of the criteria we talked about, source, how are blanks or no response treated? Or do you think this is a good visualization? Let me give you some more context. The new national survey by Pew Research Center was conducted among 10,093 US adults. Right here we have all adults and then adults that were Republican leaning and Democratic leaning. So we just have two categories of individuals. We don't have anyone who was not leaning in those two categories. We also have a note that respondents who did not give an answer were not shown. So we don't know how many people just decided not to respond. We also, when looking at additional graphs within this study, can kind of see the percentage of who was surveyed, but we don't necessarily we would have to extrapolate the raw numbers to see if they were representative of the population. We also have a note here that Asian adults were interviewed in English only, which can bring up questions of how was the translation? Did they really understand the questions that were being asked? We also have Hispanic individuals. Were they also interviewed in English only? The other question that you should be asking about is knowing your audience. So who is the audience that you're presenting your data visualization for? What prior knowledge can they be expected to have so that you're contextualizing the visualization for them and that everyone is on the same page? And I think the most important thing that you can do is citing your source when you are creating a visualization or when you're coming across one and you're trying to verify if this is reliable. Is there a source cited? So this is something that came across, that this was something that was shared within the library a couple of days ago, a cool news article about which generation reads the most. However, looking at this, we had a few questions when we were talking about it, about what does it mean when it says that the generations read the Bible for an hour or more each day. We thought that was kind of something that was atypical. We're like, oh, I don't know how many people actually spend time reading the Bible that much, devote that much time in a day to read the Bible. And digging into it deeper, actually, I think Jason went into the sources and he found that the survey was actually done for people who read the Bible, so who were Bible readers. And so these percentages, the way that it's shown within the infographic, kind of allows the audience to make a jump, that they're talking about all individuals within this population, but this is really a subset. But the way that it's being treated, it's as if the entire population is being encompassed within this category. By providing a source, someone can go in and make decisions about whether or not something is reliable or whether they would like to clarify how the information was gathered. Okay.
Okay, so now I'm going to be talking very briefly about some various map types and uses and a few common mistakes that folks make when creating maps. So the first kind of map that I make in my work, and probably the most common type, is what I would call a representative map. Some folks call it a reference map. It's kind of just like your general map that points out information. You know, so a professor will come to me, and this was made for a book. He was a medievalist, and I believe these were monasteries in early 12th century France. You know, and it's just kind of your straight up standard map that shows stuff. The next kind of map that most of you folks have come across, I'm assuming, are choropleth maps. And these are thematic maps that, instead of just showing where things are, they're actually mapping data and showing an analysis of the data. As an aside, and I'll talk on this a little bit more later on, but quite often you will see these choropleth maps that use total counts. And from a cartographic perspective, that is not best practice. Whenever you're using these, you should use a standardized or normalized data somehow. So if you have percentages or cases per 100,000 or something like that, rather than just giving the raw number. If you do want to give the raw number, the best way to go about this is to use some sort of a symbol map or a dot map, which we'll show you in the next slide. And we have two different kinds of symbol maps here. On the left, you have a graduated symbol, and what these do are they're actually taking the data and putting them into classes. And on the right, you have a proportional symbol, which just uses the number or the raw data and increases the symbol proportionally to that number. You will usually want to use, I generally like proportional symbols if the data supports it. if you have a huge variance in your data, that doesn't necessarily lend itself well to a proportional symbol because you might have one of your symbols that would obscure all of Michigan, say, which then doesn't make for a very good map. Another way, as I was saying before, you can do a dot density map, which will randomly distribute dots within an area. So in this case, this is, I should have backed up and said all those maps were made using COVID data from June, and from the middle of June to the beginning of July of this year. So with a dot density map, you would basically assign a certain value to the dots, and then the software will randomly distribute the dots within each county in this case. So Daria was talking a lot about infographic mistakes. So I'm going to briefly touch on a few map mistakes. One of the big ones is using the wrong projection for what you're trying to show. And, I could probably talk for an hour on the different ways and the different decisions you would make when you use different projections. But a very common one, if you're not familiar with, is a Mercator projection. And the Mercator projection, by the way it's designed, distorts the area of countries and continents the closer they get to the poles. And so in this case, Russia, in a Mercator projection, appears to be much larger than Africa, which is not true in the real world. If you look at a globe, and on the right-hand side, you have an equal area representation of Russia, and you can see that it's smaller than Africa. And so if you were using data that was something like lightning strikes per square kilometer or something like that, it's important that you use an equal area projection map and not a Mercator projection map, because it will be a distorted image, or it will mislead the reader if you imply that otherwise. Another kind of common mistake is if you use a color ramp like we would associate with these choropleth maps, where the darker the hue, the greater the intensity. If you're using a color ramp like that on data that does not have a quantitative scale or a numeric scale to it, that implies a relationship that really isn't there. So if you have something like state Senate districts, like these maps show, and you put a color ramp on it, you kind of look at this map on the left and you immediately start to think, well, what's going on with the middle part of the lower, or the northern part of the lower peninsula there? It's really red? Is there some kind of association with that? And there isn't. That was just randomly assigned colors, but it misleads the map reader. It's much better to have like just a random pastel palette like you'd have on the right. And so, as I was saying before, quite often when you see these choropleth maps that would be using raw numbers, it kind of can present a misleading map in that, well, for instance, in the two maps that I have up here, if you just use the raw numbers, like the map on the left, you basically have a map of the population density of Michigan. You can look and you can see, the Detroit area, Lansing, Grand Rapids, Kalamazoo are all blue or darker. And so these maps are showing percentage of people, or the respondents in the U.S. Census, the 2010 U.S. Census, that report Norwegian ancestry. And so, on the left is basically just a population map of Michigan. But then when you control for population, you can see that, the people with Norwegian ancestry are basically in the UP and in the kind of northwestern part of the lower peninsula along the coast. So it shows a much better representation of the distribution of people with Norwegian ancestry, or the kind of areas that might be more Norwegian than the rest of the state. And then this is kind of getting into what Daria was talking about earlier with kind of misleading maps. And as a map consumer, you should be aware of this as well, because it's very easy to design a map to show whatever you want it to show. So both of these maps here have the exact same data. It's just classified in different ways. The map on the left makes it look like COVID is running rampant in the state, and everybody's on fire. And the map on the right basically makes it look like there's only like 4 or 5 counties that are in any kind of bad shape. And it's the exact same numbers. I just scaled the classifications differently. So don't do that, or at least be cognizant or careful when you're making your maps or your graphics. A couple of other common mistakes here. We have what's called the ecological fallacy. And so if you look at this, if you have two equal areas, one is 10% and one is 20%, you can scale those up and make that as 15% for the whole area, but you can't take half of one and half of the other and average them out and make a square in the middle that is 15%, because you can't assume that things are distributed normally. Similarly, there's a idea in geography called the modifiable aerial unit problem. And that is basically the concept that you can get different results from your analysis depending on what area or what the size of the area that you're looking at. And so, you see these kind of electoral maps every election where, the whole state is colored one color or the other, whether it goes Democratic or Republican. And that makes for a visually captivating map, or a very distinct map, but it's not necessarily a good depiction of reality. And then so on the far right, you've got your kind of traditional electoral college map, and then next to it you have the electoral college map by county. But when you assign an either or a binary scale, once again, that's a little misleading. And kind of when you look at the bottom map there, that's actually kind of a better representation of what's going on when you have a much more purplish map than one or the other. And that's, once again, this is getting into we're still assigning a lot of red to open areas. So we could get into a cartogram, but that's a whole nother visualization for a different day. So yeah, next slide, Daria. One other common thing that we get with maps is when you assign kind of arbitrary man-made units to natural phenomena. So on the right, we have solar potential by a 10-kilometer grid. And then when you aggregate them down into states, it sometimes can present a misleading or not as quite of a accurate understanding of what's going on. Because if you were in Nevada, say, southern Nevada is an excellent area for solar potential, but because it has less area than the northern area, when you average them all out, it suddenly becomes just very good instead of excellent. And then the last little thing that I have here is what I kind of just call poor symbology. Sometimes, if you have a lot of data and you just dump it into a map, you won't be able to really see much. So the map on the left here is showing tornado touchdowns in Michigan between 1950 and 2004. If you look at that map, other than the fact that there were a lot of touchdowns, you can't really make out much. If you run a kernel filter over it and derive the density of the tornado touchdowns, you can see that there's some weird thing going on around the Saginaw area where they have a ton of tornadoes for some reason. But yeah, just you have to kind of think about how you want to display your data appropriately.
Yeah, I really wanted to go through some data types and uses. We are running low on time, so in the interest of time, I'm just going to go really quickly. And then when I share the slides, you'll be able to kind of go through it yourself in more detail. But basically, we have a few different types of graphs that you will probably run into. It's important to know what is used for what, just like Jason demonstrated with the maps, that there are specific types of maps you should be using for different types of data. Bar graphs are really the ones that are categorical, so data that is not dependent on each other. Really want to use a bar graph and make sure things start at 0 is very important. Line charts show you changes in data over time, so making sure that things are consistent as you move along the x-axis so that there are no time skips, so everything is continuous, is important. Having a pie chart is nice when you're trying to show parts of categories. It is important that you don't get carried away with how many slices you have, because then at that point, things get kind of muddled and you're not able to see the actual categories. And it's also important not to force comparison against across pie chart. So if you have one pie chart and then you're comparing it to another one, maybe you should be using a bar graph instead. And the last one is a scatter plot. This one is to demonstrate variable relationships. So if you're doing some sort of correlation, it is always very good to have a trend line so you can see how the relationship is moving, and also really good labels and subtitles to allow the audience to know what you're depicting. I think to finish off, we're just going to leave you with a few tools. So Jason, take it away.
Yeah, so ArcGIS is an Esri product, and it's kind of the most expensive and most full-featured of these. If you're a geography student or a geosciences student, you'll have access to these, but otherwise you basically have to take a class to learn how to use them.
Yeah, and we have some computers and on campus that have ArcGIS.
Yes, we have one. There's a map. Well, eventually there's a map. There's a computer in my office that is available when we open up to the public again. QGIS, if you want to do this on your own, it is a free open source GIS platform that is pretty feature packed, and it is comparable to Esri. It's not quite as polished, but it's free, and you can download it from the link. And then the last one, if you just want to learn stuff about, you want to measure out the distance of paths, or, figure out the area that a certain city covers or something like that, you can use Google Earth Pro. It is free and it's very easy to use, but it has a somewhat limited tool set.
In terms of data tools, Excel is probably what you'll find most often. And you have a subscription to it through Office 365 with your Bronco ID. So if you haven't downloaded that, what are you waiting for? In addition, Tableau is a good option. If you are a student, you get a free year subscription that's renewable. You just have to verify your credentials by signing up. But I would highly recommend this. It also has some mapping capabilities as well. And there are also a hodgepodge of different types of data tools. Depending on what you're trying to do, I would encourage you to explore and see what works for you if those two first ones don't. We have compiled some resources for you to pursue at your leisure, such as what chart should I use? I am not sure based on your presentation. There is an infographic that will guide you through that. We also included some links about when you should choose a map over a chart, or maybe a chart over a map, depending on what you're trying to show your audience. And because it is so important to pick the right colors, there's also a link there about things such as color blindness or picking your palette and what things you should consider. We are also both resources that are available to you at the library at your disposal. So Jason and I both take appointments. We are also available via email. So if you have any questions, comments, concerns, thoughts, or need help with a future project, please reach out to us.
Yes, we're here for your help, or to help you.
I am including in the chat the link to your slides. Thank you so much for coming to our workshop. Hopefully you learned something, or at least have something to think about. If you can help us out and participate in a survey about this session, that would be great. I'm also pasting that within the chat. Just take a few minutes to let us know what you think. We also look for feedback about how we can improve the session or provide something else if there is something else you would like to hear about. I would also encourage you, while you are taking part in library skills, to take part in all the wonderful workshops that are coming up. We have many that are going on because this is going on through Friday. I'm actually hosting another workshop on Thursday. So, I'm sure my colleagues all have fabulous presentations prepared for you. So please take advantage. And I think that's it. Thank you so much, everyone. We will
Thanks
stick
for coming.
around for 8 minutes.